determining the domain and range of the graph of a function. So now we're going to actually look at graphs and stating domain and range. So remember, domain always has to do with our x-axis, and the range always has to do with the y-axis. So if we look at this first graph here, if I want to, and you know what I'm going to do is I'm just going to extend this. I'm going to put a little arrow at the top there, just because here we can see that there is a point there. There's a point right there, which means that that graph ends, but there isn't a point there. So I'm going to put an arrow, which means that it just would extend forever. Okay, and we're going to get the domain and range. So we're going to look at two different notations. The first notation we're going to look at is called interval notation. Now, interval notation is used, we use brackets to help us with it. So a square bracket means that it includes the value. Okay, includes. And a circle bracket means that it does not include. And I'll show you what that looks like when we do some examples. The other thing with interval notation is it implies all real numbers. Okay, so when we do put our numbers in between these brackets, we imply that it's all real numbers, every number in the real number system. So let's take a look at the x. We want to first look at our smallest x value. So this arrow means that this line here is actually continuing up and to the left just a little bit, which means that it's going to go left, which means that these x values are going to get smaller. So for the domain, I would say that the smallest x value is negative infinity. And I'm going to do a circle bracket negative infinity because I don't actually know what negative infinity is. So I can't say that it includes negative infinity. And then I'm going to put a comma, and I'm going to put the highest number that it reaches on the x-axis. So the highest number that it reaches is 3. Here's 2, here's 3. It doesn't go anywhere past 3. So I'm going to put 3. And then, because it includes 3, I put a square bracket. All right, now I'm going to work with range. So with range, I put R, and I take a look at what is the smallest point on the y-axis. The smallest point on the y-axis here is -1. So I'm going to put, it includes -1, so I put a square bracket. It touches -1. And then, again, I know it stops over here at this dot, but this arrow here on the left side shows that it keeps continuing on and on and on, up, which means that the highest point on the graph will actually be positive infinity. And then I put a circle bracket to show that it doesn't include positive infinity. All right, I'm going to just use up some room for B, and then I'm going to get you guys to try B on your own. So I'm going to do set notation next. So set notation is just a fancier way of doing domain and range, okay? It tells us the exact same thing as interval notation. You'll probably see set notation a little bit more often, especially in the -1 stream, okay? So we start set notation with a curly bracket and an X, and then we put a bar there, and the bar stands for such that, okay? X such that. So I just say X bar, but you can say X such that if you want. All right, now I need to look at my graph, or I can look at my interval notation, whichever, and state what our x values are. So I know that my x value here, if I go back to my graph, has to be smaller than +3. So I would say x has to be less than or equal to, because it can equal +3. Now, if it can be less, or if it is less than 3, x is an element of the real numbers, XER, and then I do a curly bracket. Now, the same thing happens for range, y, so curly bracket y such that, and then I'm going to take a look at what y is. So if I take a look back at my graph, my lowest value is -1. So I say y has to be greater than or equal to -1. As long as it is that, it can be an element of the real numbers, YER. So that is interval notation using brackets, and set notation still using brackets, but just curly brackets a little bit fancier. All right, let's try C. So for C, first I'm going to take a look at, I'm going to do interval notation first. Okay, so interval notation first I'm going to do my domain. So I want to know, okay, x here, so that's -3. That's my lowest x value. My highest x value is +5. So what I'm going to do is I'm actually going to write what that would look like as an ordered pair. So -3, and I'm going to write my y value as well, and that is +3. And then this ordered pair here, if I just asked you to write the ordered pair, you would write it as 5 and 7. Okay, you would just write those if I just asked you what that point was and what that point was. So these points are going to help me with my domain and range. So domain, my lowest value is -3. There is no point that this graph is going to get any lower than -3. I will never write an ordered pair for this line here that's less than -3. It touches -3, so I use a square bracket, and it goes up to +5 here, and it includes +5 as well because it touches +5. So I use square brackets to include those. Then for range, I do the same thing. I look at my smallest value first. So my smallest value is +3. It includes +3 because it's touching +3. And my highest value for y is +7. Okay, this value up here, it's as high as the graph is going to get. There's no way I could write an ordered pair for this graph that would have a y value greater than 7. So that is interval notation. Set notation. Remember, just the fancier way. So we're going to do curly bracket, x bar. And now because I have two numbers that it's between, I'm going to do something called an x sandwich, okay? So the x sandwich says, I'm going to put my lowest number first, so -3. Then I'm going to put x, and I'm just going to leave a space between there. And then I'm going to do +5. Now, x has to be greater than or equal to -3. If I'm looking either at my graph or even at my interval notation, and less than or equal to +5. As long as it is between those two numbers, x is an element of the real numbers. For range, where do I want to fit range? I think I can just squeeze it in here. Let's just do it here. Y such that, now my lowest number for y is 3, and I'm going to do something called the y sandwich because I'm sandwiching my y in between those two numbers, and my highest number is 7. Now, y, we always read from the variable, is greater than or equal to 3 and less than or equal to 7. Okay, so always read from that variable. Y is greater than or equal to 3 and y is less than or equal to 7. As long as it is between those two numbers, we say y is an element of the real numbers. So that is interval notation and set notation. I'm going to do one more with you. I'm going to do F with you. And I want you to try B, D, and E on your own, and we'll post the keys so that you will know if you're getting it right or not. Okay, so let's do F. So these little arrows here at the end of our graph, if I'm going to do interval notation, the little arrows say that this graph is continuing to go down and to the left for infinity. We don't know when it actually is going to end, which means that my lowest x value is actually -infinity because it's going to the left, which means my x values are getting smaller, smaller, smaller. Then my highest x value, I'm following this way here to the right, is actually +infinity, and I close infinities always with round brackets. My range, my lowest value for range, again, if I follow these arrows, it's going to end up as -infinity, so circle -infinity. And then the very top of the graph, here's 5, so the very top of the graph would be 4. It's never going to go any higher than this line here. So that means that my highest value is 4. So that's interval notation. Now set notation, curly bracket, x such that, and then when it is -infinity to +infinity, it's really easy for set notation. We just say x is an element of the real numbers. That's it. And for range, y such that, now not as easy because the highest number is 4, so we need to say y is less than or equal to 4. As long as it is less than or equal to 4, y is an element of the real numbers. Okay, I'm going to stop there, and you're going to finish B, D, and E, and also try the extra practice.